Hi folks, welcome back. I hope you're all doing well. Today I want to take a look at a paper from Microsoft called Autodev, which presents an agent-based LLM system to perform a bunch of software engineering tasks. And it was released either the same day as or the day after that Devin AI was released. So that's interesting because what this is proposing, I think, is very similar to what the Devin demos were showing. So the basic idea of these agent-based systems is that if you look at things like Copilot in your editor, they offer code completions, but they don't help with automating all the other parts of the software engineering cycle. Things like invoking tools or compilers or invoking tests and then acting on the feedback of those tests. So once Copilot gives you a completion, all those other activities are still performed by the human software engineer. And those are exactly the things that systems like Autodev want to automate. This is the overall architecture of the system. Some of the main components here are a tools library, and this is a collection of all the actions that the LLM can invoke. Things like editing a file or looking up things about your code base, maybe with tools like grep, actually building and running your source code, executing tests, performing source control operations with Git. All those things make up its library of tools. The real smarts of the system are actually inside this conversation manager component, and also to some extent in the agents themselves. But the job of the conversation manager is to take the objective given by the human and then orchestrate the agents iteratively to perform that task. So this conversation manager is invoking agents. It's looking at the output of those agents and parsing them. The output of these agents, which is output from LLMs, will contain places where they want certain tools invoked. So the parser looks for those things and invokes those tools on behalf of the agents. The output of the tools comes back to the conversation manager, which, depending on where you are in the cycle, might get passed back to agents to then iterate on the problem. And this whole orchestrated dance continues until the initial objective is met. I really wish the paper had included the prompts they used for the conversation manager and for some of the agents themselves, but lacking that, let's look at the next best thing, which is a concrete example that demonstrates their flow end to end. So we start with a human that says, I want to write a Python test with some assertions to cover the following code. And this is code that already exists. And the human tells the system, this is the name of the file in which I want you to add the tests, and they should be written in this format. All right, so this is where the agent takes over. I'm guessing it invokes an LLM agent, which is asked to generate test for this given code, and it comes back with some proposed code for a test. Notice the tool call over here. One of the tools available to the system is to write and edit files. Here it's writing an entirely new file. And then the agent is invoking a command to run these tests. Now, when these tests are run, it comes back with a failure. This failure is piped back to the test generation or the test debugging agent, which is then asked to debug why this test failed. And here you can see some reasoning that it's doing to find out the reason that this test failed. And based on that reasoning, the agent decides to edit this one line in the test. It writes that back, invokes the test again, and this time the test passes. And this accomplishes the original user objective. So you can see in this example how this entire coordination between multiple tools, multiple agents resulted in accomplishing the initial goal. If you were just using Copilot, you would probably have gotten this code completion in your editor and all these other things like running the test and maybe asking Copilot again to debug the reason why the test failed. All those actions you would be doing manually. And this is what this agent-based system is automating. So how does this approach perform? If you look at the GPT-4 baseline with 0 shots, so no examples in the prompt, on the human eval benchmark, it achieves a 67% pass at one rate, which means the first proposed attempt passes. Autodev brings that all the way up to 91.5. Now, if you look at the human eval leaderboard, there's actually another approach, language agent tree search, that does better than that, but that approach needs more training. Autodev achieves the same effect without any extra training. If you're curious about the human eval benchmark, my previous video talks about that and some other common benchmarks that are used to evaluate LLMs. Now, if you look at test generation rather than code generation, again, the GPT-4 baseline only has about a 75% pass at one rate, and Autodev brings that up to 87.8. So all this is to say that using all these agents in concert brings up the success rate compared to using a plain LLM by itself in a 0-shot setting with just one completion. So that was a quick look at Autodev from Microsoft. It takes one more step past systems like Copilot to automate basically the entire developer flow, not just suggesting code completions, and achieves some pretty decent results. I hope you enjoyed that, and if you like content like this, please like the video, consider subscribing, and I will see you all next time. Thank you very much.